All right, so we know what z-scores are now, but we still haven't talked about how to find the probability of getting an outcome between two values, even though we can find the z-scores for those values. And in order to do this, we're going to be looking at something that's called a standard normal distribution. What the standard normal distribution is, though, is just any normal distribution in which all of the raw scores or original variable values that you have been converted to z-scores. And what happens when you do this is that you get the same units, mean, and standard deviation for your normal distribution, which is why it's called a standard normal distribution. So when you convert everything you have to z-scores, so in the example we have, if you were to convert every different number of thefts to z-scores, you would get a standard normal distribution. And in a standard normal distribution, the following things are always the case. The units are z-scores. So you're not counting in numbers of thefts anymore, you're just counting in z-scores. And in the example there, if those are SAT scores, you wouldn't be counting in, which I'm guessing based on what numbers they are. Again, I just steal graphs off the internet. You're not counting in SAT scores anymore. Now you're counting in z-scores. When you're counting in z-scores, your mean is always equal to 0. This is because a z-score tells you the distance away from your mean in standard deviation units. Well, the distance away from the mean is always 0. So the mean always has a z-score of 0, and in a standard normal distribution where everything is converted to z-scores, the mean of the whole distribution is always 0. And the standard deviation is always 1. So if a z-score is the number of standard deviations away from the mean, well, one standard deviation away from the mean is going to have a z-score of 1. So your standard normal distribution has a mean of 0, a standard deviation of 1, and no matter what you're starting with, if you convert everything to z-scores, you're going to come out with a standard normal distribution where you have a mean of 0 and a standard deviation of 1. And this is what we are going to use to find the probability of getting an outcome between two values. So, probability of getting some outcome within a range of values. Well, what we know is that the proportion of the area under the curve between those two values is equal to the probability of getting an outcome or an observation between those values. And we're going to use that fact, along with that standard normal distribution that we just came up with, to be able to find the probability. And there's two steps that we're going to follow that are going to use these z-scores and standard normal distribution. The first thing that you do is convert your values to z-scores that you're interested in. So whatever range of values you're looking at, you're going to convert those values to z-scores. And the next thing you're going to do is you're going to find the area under the curve between those z-scores. And because once everything is converted to z-scores, you have the same normal distribution each time, the standard normal distribution, you don't have to worry about your original units or values. You can find the area under the curve between the two z-scores in a standard normal distribution, which, because it's the same each time, is standardized. In other words, it's something that you can just look up. So in order to find that area under the curve, you're going to use something called a z-table, which is just a list of the different areas under the curve in between the mean and different z-scores in a standard normal distribution. And again, this is something that's just been listed out, it's already been calculated, it's already been figured out, and it applies to the standard normal distribution. But because you can convert any normal distribution to a standard normal distribution, you can convert any normal distribution that you could see in any problem into something where you can just look up the area under the curve between the mean and a particular z-score. So the last thing I'm going to do today is go over to the document camera and go through some examples of finding the area under the curve between two values using a standard normal distribution and a z-table.